Let's talk about a few technical things. What text are we using? We are using Chemistry Atoms First, and this is an open educational resource. We do this because it is cheaper. If you actually only work with the electronic copy, that is free. If you want a copy, an actual hard copy of the text is about $50, which is just the cost for them to print it. And we coordinate this with the Chem 141, 142 sequence. For those of you that will end up taking these sequence, you will see this textbook again, so you don't have to buy another one. We cover about the same topics as is covered in 141, 142, but not as in depth. So we cover same concepts, not as in depth, and that's why I am going to direct you on which chapters to read out of this textbook, and which sections of each chapter, because the Chem 141, 142 covers a little more than what we do. Obviously, the first reading assignment is the chapter 1, all sections of chapter 1. All the sections that you will need to read are listed in the syllabus. If you print out the syllabus, which I highly recommend, you look in there, there's a list of, it's kind of a schedule for the lecture and lab. It's a tentative schedule because it sometimes changes, but it's a schedule that we're going to try to adhere for the class. So print it out, and then all the chapter sections that you need to read are listed in there. That will be very helpful for you. Here's the outline for chapter 1. We have section 1 from 1.1 to 1.6, and we're going to talk about each of these in turn. Let's focus on the first one, chemistry and context. Section 1.1. Well, chemistry is obviously the branch of science that studies chemicals. It's always been there, even though we may not have thought of it as chemistry. And I dare say most of the people who aren't necessarily into science, they don't really think in terms of chemistry. They don't really think in terms of chemicals, although we use them every day. Chemicals are in our food, they're in the water. Water is a chemical, even though we don't think of it as a chemical, but it is. So it's everywhere. There's these 2 points are basically it's always been there, and it will be, and it's everywhere. Everywhere we turn around, all our clothes are made of chemicals. I mentioned food, what we eat, what we are made of chemicals, even though once again we don't think about it, but we are. So look at chemistry. It's kind of a central science because it can branch out to so many other sciences, and it ties into so many other sciences. Chemistry you can go into engineering. That's a crossover to engineering, chemical engineering, material science, a huge branch right now. Nanoscience, nanotechnology, huge right now as well. Chemical physics, it's a crossover to physics and mathematics and nuclear chemistry and environmental science, biochemistry and molecular biology. These are my 2 loves. I'm a chemist, but I really love the chemistry of the body, the biological systems, living things. Whereas my husband is mostly into this branch, mathematics and physics and chemistry. So you'll find many divisions of, or you find chemists working in not just chemistry as a central science, but crossing over to many other different disciplines. So it is everywhere, and it's always been there. We've just discovered bits and pieces of it as a history of mankind has gone along. And it will be there long after we're gone too. So it's an interesting science to me, and I love it because it does cross over to so many other branches. So it gives you a wide field. If you are a chemist and you do very well at chemistry, you understand very well, you can cross over into many other different sciences and do them just as well. First of all, though, after we talked about this, all the sciences,